Hello, and welcome to the Unit 6 Properties and Algebraic Expressions Study Guide Review. Problem number 1, 93.2, or 93 and 2/10, minus 4 and 3/10 to the second power, plus 2 times the quantity of 6 plus 4. So for this problem, we are going to, follow order of operations. Let me get my right color. So we're going to follow the order of operations, and our first order of operations is parentheses. In my parentheses, I can do 6 plus 4, and then I'm going to bring down the rest of my problem. And my next step is 4.3 to the second power for my exponents, so I'm going to use my calculator. And that equals 18.9. And I'm going to bring down the rest of my problem. And then I'm going to follow my typical order of operations, so subtracting first. And that is 74.21 plus 20. So my final answer will be 94.21. For problem 2, Adam has $450. He spends $210 on food. Later he divides all the money into 4 parts, out of which 3 parts were distributed and 1 part he keeps for himself. Then he found $50 on the road. Write the final expression and find the money he has left. So initially on this problem, I overthought it and was doing all kind of weird things because I knew to divide by 4, but then I was like, if he's only keeping 1 and he's giving 3 away, I've got to do something else with that information. When in fact, I was right in the first place. So when I had my original expression of 450 minus 210 in parentheses, and then all of that divided by 4, that was fine because when we divide by 4, that's giving us what 1 part equals, and he's keeping 1 part. He gave 3 parts away. So this was fine, but then I also have to add on the $50 that he found. So when I do this, he has $230 divided by 4 plus 50. And when I divide that, made a mistake. We're here, 240. Sorry about that. So 240 divided by 4, that equals $60 plus 50 more that he found, lucky guy. He ends up having $110 left over. All right, number 3. The rope in the school gymnasium is 10.5 feet long. To make it easier to climb, the PE teacher tied a knot in the rope every 3/4 of a foot. How many knots are in the rope? So now we're having to visualize a long rope, and we're making it into 3/4 sections. So basically when we're doing this, that is essentially dividing. So we're going to do 10.5 divided by 3/4. And when we do that, I'm going to make this into an improper fraction. So that's going to be 21 over 2 divided by 3/4. And we're going to use the reciprocal so we can multiply. So it's going to be 21 over 2 times 4 over 3. And when we multiply that, 21 times 4 is equal to 84 over 6, and that's going to equal a total of 14 knots. So he's going to have 14 knots on the rope to help kids climb up. Number 4, the student council has 45 members. Of these members, 3/5 are boys. How many boys are members? So for this one, we have a total of 45 kids in the student council. So I need to find 3/5 of that. So that's a multiplication problem. So times 3/5. And when I multiply straight across, that equals 135 divided by 5. And that equals 27. 27 boys. And let me go back and make sure that makes sense. So I know that 3/5 is more than half, so my answer should be more than half. And half of 45 is in the low 20s, so that suits the answer. Number 5, Daniel has 3 times as many stickers as Mackenzie. She is very jealous. Daniel has 168 stickers. What expression can you use to find S, the number of stickers Mackenzie has? So for this, I'm going to say, so it says Daniel has 3 times as many, and she has S number of stickers. So the expression is going to be 3S equals 168. Because Daniel has 3 times as many as Mackenzie, and in total Daniel has 168. So next unit we're going to explore how to further figure out how many Mackenzie has, but essentially we're going to be dividing 168 3 ways, and she'll have one of those ways, one of those parts for the stickers. But for now, this is all you have to do for this expression, or really it's an equation because of the equal sign. Number 6, a customer needs 3 bottles of orange juice and 2 pounds of apples. Write an algebraic expression to represent the situation on a cost of J per bottle of orange juice and Y per pound of apples. So this one is going to be 3 bottles of orange juice, and orange juice represented by J. So it'll be 3 times J plus, because we're adding the cost together, 2 pounds of apples. So 2 times Y, and then that will be your final answer, and that's going to give us the total cost of going to the grocery store. Number 7, for 7 through 10, we're writing an expression to represent each of the following. So number 7 is 8 less than a number is 23. So I know when we say is 23, that's the equal side, that's the part that says that's the answer. So 8 less than a number. So we have a number and we have 8 less than that. So it's going to be a number minus 8. Number 8, a number is decreased by 12. So this time we have the number, we take away 12, and that's the expression. Number 9, the product of 7 and P minus the product of 11 and Q. So we have 2 things happening. We have the product of this one, and we have the product of this, and then we're taking away those 2 things. So this is going to be some grouping for us. So the product of 7 and P, which is going to be 7 times P, minus the product of 11 and Q. And I'm putting them next to each other like this because that represents 11 times Q in 6th grade, getting into more advanced algebra. You could have said 7 times P, but I'm looking for getting into this fashion. Number 10 is the difference of 7 and P multiplied by the difference of 11 and Q. So this is similar to the problem beforehand, except we have a couple of things different. This time we want the difference of 7 and P. So that's going to be 7 minus P. That's the difference of those 2. Multiplied by, that's our multiplication symbol, the difference of 11 and Q. So again, 11 minus Q this time, not the product of. The product means multiply, the difference means subtract. For problems 11 through 14, we're writing a verbal expression for the following expressions. So these are our algebraic expressions, so now we're going to go this format. So this time we have 6P plus 15. So I'm going to say the product of 6 and a number increased by 15. And again, there's multiple ways to say this. You could put 15 more than the product of 6 and a number. But undo that. Okay, So next one is 390t. So this can be the product of 390 and a number. Number 13, 8 and y minus 7. So we know this is the distributive property, but we're not going to just simply say 8 distributed to this. We're going to say, I'm going to say 8 times the sum, sorry, not the sum, the difference. Apologize. So 8 times the difference of a number and 7. And again, there's multiple ways you could have said that, but this is the one I recommend, 8 times the difference of a number and 7. You could have said 8 times that's the one I would recommend. The next one is 18 divided by b minus 7. So I recommend saying the quotient, because division is represented by quotient. The quotient of 18 and a number decreased by 7. You could have also said 7 less than the quotient of 18 and a number, but I wasn't thinking that when I started writing, and I would have had to erase everything. So the quotient of 18 and a number and all of that is decreased by 7. And I know it's decreased by 7 because the quotient tells me to do that part first and then decrease it by 7. Alright, number 15, use the distributive property to rewrite this expression. So for this, you need to know that your 8 is distributed to both parts of the problem. So this is going to be 8 times 2a plus, because we have a plus sign here, 8 times 5. And I think I'm good if you want to stay there. If you took it further to solve it, it would have been 16a plus 40. But since I said just rewrite the expression, all you had to do is this part here. You didn't have to simplify it. But you could if you want to. Number 16 is to simplify the expressions. This is where I have to find like terms. I have 2t, I have a negative t, so that's going to be one like term. I have x's, and again I'm circling the operation with it, and I have a constant. So my 2t minus 1t is a plain t because there's a 1 there. My 4x positive and my 9x positive is going to be positive 13x, and then my constant didn't have any other constant, so it's just going to be 19. And that is in simplest form because t and x and constants don't have any further terms in common. When we're adding and subtracting, you have to have like terms. Simplify this expression, and these should have been squared, but my copying didn't work that way, so I'm going to fix that when I go to make my answer. So I've got 9v and 13v that are like. I've got a positive 5v to the second power, another positive 5v to the second power, and I have a constant. So 13v plus 9v is 22v, and then 5v squared plus 5v squared is 10v squared, and then 18. And remember, I can't add these two together because v squared and v are two different variables. They have to be exactly the same. Number 18, simplify the expression. So following my order of operations, I'm working with my parentheses. I can't do anything right now. I don't have any exponents, so I take on to the multiplication. I have to distribute my 2 to this problem, so it's 2 times r and 2 times 6. So when I do that, 2 times r is 2r, 2 times 6 is 6, and then I bring down the rest of my problem. So then now I can combine like terms because I'm only adding and subtracting. So now I'm back to 2r minus r, which will be 1r. And then I have my constants of 6 and 5, both positive. So it'll be r plus 11. Evaluate each expression using the given replacements. It looks like I cut off my problem, so let me find the rest of it. Okay, there we go. Okay, so A is equal to 2, B is equal to 5, C equal to 8. So I just need to simply substitute in my values. For every A I see in my problem, it equals 2. I only have one of them, so it's going to be 2 plus, and then 2C, so it's going to be 2 times whatever the value of C is, which is 8. So then my final answer will be 18. So 2 plus 16 is 18. The next one is getting a little bit more complicated. I have many more things to substitute in. So I'm going to substitute in my B, which was 5, my C, which was 8, and then I'm going to go into, for the sake of being easy right now, 2 times 2 is 4. So I just went ahead and did that in my head. And when I simplify this, I'm running out of room. And when I total all of that up, 15 plus 8 is 23 plus 32. And then that equals 55, I believe. Let me check my work. Whoops, it's not plus, it should be equals. Let me fix that. Okay, next, whoops, sorry about that. Next problem. So identify each part of the expression. So this is where I'm wanting you to tell me variable, constant, coefficient, quantity, all of those terms literally for the expressions. So in this expression here, S is a variable. So that's all I'm wanting you to say is S is a variable. So is Y. Y is another variable, but right now just S. 8 is a coefficient because the coefficient is the number before a variable. The constant in this problem is 19. So 19 is your constant. And then how many terms are there? So we have 1, 2, 3, 4 terms in this problem. They're separated by addition and subtraction signs. All right. Next one, I apologize for the graphics, but I just couldn't copy and paste very easily, so that's just what we've got. So name the property illustrated by each expression. So this one we're dealing with the commutative property because it's the same numbers, they're just in a different order, and that's what you're allowed to do with a commutative property. So commutative property. The next one, we have the distributive property because we see the breakdown over here, and this is the original expression, and 6 is being pulled out from each one, so that is the distributive. The third one is the same thing. This is an equal sign right here. We have the flip-flop, so we have the original expression, and we have the 7 distributed to both parts of the expression. The next one, we have the same order, the numbers are in the same order, so that's a sign that you're dealing with the associative property. What changes is the groupings. So when only the grouping changes, that is telling you that it is associative property. And make sure you're getting the spellings correctly because that will count on the test tomorrow with the spellings. And finally, we have another example of the commutative property dealing with variables. It doesn't matter whether you have variables or numbers, constants, the same property is represented. So it is commutative. All right, moving on to our last question. Using the expression 2 times the quantity of A plus B to the C power, so I couldn't, again, you can't put a C as an exponent, so that's represented by that power of, what values for A, B, and C will be the greatest value? So I'm going to go down here and I'm going to substitute in each of these for the problem, and I'm going to work out each one. So for A is 6 and B is 3, and that's to the second power. Problem B, I'm just going to write them all down first. Problem B is 2 times the quantity of 6 plus 2 this time. And then C is the third power. For C, we have 2 times the quantity of 10 plus 6 to the fifth power. That's looking like it's probably the biggest one. And D is 2 times 10 plus 4 to the second power. So let's need to go back and solve these now. I'm going to start with the parentheses. So this is going to be 2 times 9 to the second power. 9 to the second power, so that's parentheses. Exponent goes next. 9 to the second power is 81 times 2. And that's 162. Oops. So for this one, we have 2 times the power, 2 times the quantity of 8 to the third power. And 8 to the third power is 512. So 8 to the third power, and then we multiply that by 2. And we get 1,024. And then next one I've got 10 plus 6 is 16 to the fifth power, which is gigantic. Wow, that's huge. So that's going to be so 1 million and change, and then we get to double that. So that's going to be 2 million and change. So that's definitely going to be the largest one. So 10 plus 4 is 14 to the second power. And that's 196 times 2. And that's 392. So for this problem, it looks like when that exponent got up there, that really influences the problem greatly. So letter C will be your greatest value for this problem. But I encourage you, whenever you're given a problem like this, go ahead and solve all 4 of them so you can make sure you have an educated choice.